We've left a little bit of time at the end just before lunch for our panelists to give about a 5-minute summary preliminary recommendation, basically to summarize the highlights of things they would recommend as a result of their review and evaluation. Would it be all right if we could change the order maybe from this end to that end? Would that be a change of pace maybe, and start with Larry?
Sounds good to me.
And actually, if Claire wants to join the audience, you're not going to have to be focused on this at all. So. Thank you very much, too.
Yeah, I've got a few comments, few take-home points, if you will, from the past day and a half of observation and sort of questioning what's been going on. We've been tasked to review 5 years of a baseline study, but it's hard to just let it go at that and not think about the future and what might be coming along as the mine is developed. And so because of that, I've got some questions in my own mind that I've come up with that I'm going to repeat here, and we can sort of just ruminate over them a little bit. One of these is that, we've got the Usabelli coal mine up the road here that has been working for, over 40 years now. And they have a mine land reclamation effort that has been a pioneer for cold climates. And I know for a fact that in the beginning they just were throwing seeds out hoping something would grow. But they've become very sophisticated in their reclamation work, and it's become a very successful effort. And I hope that the people at Pebble will take advantage of this expertise and see if a lot of that can't be transferred over to where they'll be working. Also, the NRCS in Palmer has established along the transatlantic or Trans-Alaska pipeline route a number of reference soil sites that they monitor and look at. And I'm sure that they would be interested in setting up similar reference soil site areas in the Pebble Prospect region if they were contacted. I know for a fact that there aren't any of reference sites out there right now, so it would be a matter of getting a hold of them and working with them to set up these sites. I think that would be worthwhile doing. Let's see, what else? Yeah, the work of Clark and Ping in the Chiswick Island area is one of the references that we have for soils of the region. There are also a couple of studies that I'd like to call your attention to that have occurred in the west of Tyonek in the Caps Coal Field area, and these are USGS open file reports dated in 1983, and they're 83-190 and 83-246, and these were these studies involved the characterization, not only the characterization of the soils, but also the geochemistry, and they'd be worth looking at least from a reclamation perspective. Yeah, the studies that were that were looking at soil basically were three that I could find. We had the small scale 1 to 1 million background and literature study that Greg talked about yesterday. And as far as I can tell, there wasn't a whole lot of integration between that one and the soils that were described in the vegetation study, and also, which will be reviewed next week, I guess, and the soils that were characterized in the trace element methods section. But I think there needs to be a little bit more integration among these efforts to look at not only the geochemistry of the soils, but also the physical character of the soils. I've got a few more points, but I think I'll let it go at that at this point. And yeah, so if there are any questions, I'd be happy to answer those.
Okay, well, probably in the interest of time, we'll move on to Steve.
Okay, I'll give a brief review of some of my recommendations for particularly the seismology and the volcanology part of it. The first one, I think there's justification at this time to do a first-order probabilistic seismic hazard assessment. At the very minimum, you want to give the relative hazard for the various sources that have been identified, the subduction zone, the deeper slab events, the local ones, and then this idea of a floating event. For example, you could give a table that shows the distance to the source for each of the sources, the magnitude range, the recurrence rate, the likely shaking amplitude, the period, and then so you want to be able to quickly at a glance get the relative hazard from these different sources. Because the data are dynamic and readily available, we need to assure that there's dynamic data gathering capability. For example, the ability to update plots of earthquake occurrence and the relations on the web page, for example. Explicitly consider the effect of earthquakes on the transportation corridor, particularly the Bruin Bay Fault. The Iliamna deep cluster should be considered along with the as one of the three sources in the relative hazard stated earlier. And with those data, then you can then determine the likely risk for the 30 to 35 year period during which the mine would be expected to be active. The soil conditions and the effect of overburden removal need to be explicitly considered. I think there needs to be explicit statements of the variance. One comment drifts a bit into some of the discussion today. I think I haven't heard it mentioned explicitly. We want to make sure that the shaking hazard is included in the tailings design. One can imagine a pile of loose rock and you shake it in a magnitude 8 earthquake 100 kilometers away. There would clearly be some kind of effect that needs to be considered. I think whether the Lake Clark Fault extends further to the southwest is still an open question, and we need to at this point clearly define the difference between the hazard, which appears to be low because of low activity, and the risk, which is high because it's the closest main fault to the activity. So one way to approach this would be to do a sensitivity analysis, do a comparison with the present known location of the Lake Clark Fault to see what the formal hazard is, and then extend it farther under the mine and repeat the analysis to determine what the effect is from that uncertainty. Okay, that's the seismic side. On the volcanic side, I think several of the volcanic centers to the west need to be explicitly considered. Katmai, Novarupta, which is one of the vents in the Katmai region, Aniakchak, and several of the other major peaks, explicitly put in information about the wind direction and speed, the wind rose diagrams, because a lengthy eruption there would dump a lot of ash, which would show up in the mine site and would be an ongoing concern. For example, you wouldn't be able to operate aircraft if there was a long-lasting eruption. Determine the size of the events and the frequency of occurrence. And those are my main recommendations at this time.
Steve, I had a question. Yesterday you mentioned the possibility of, or the suggestion of, a small seismic network associated looking at small small movement on potentially along the Lake Clark fault extension. Are you still?
Yeah, okay, I'm fighting a little war with myself here. I mean, my comments that I gave so far were directed strictly at the study as it exists and the information we were asked to evaluate. Whether you extend that by adding a seismic network, yes, I would like to see that done. I think it would be a good idea. I'm not sure exactly where that fits into the current process. I will make sure that I contact some people and see whether this is feasible to do this. I think it would add, but it's not something that has been done yet, so it's not clear exactly where it fits in the present scheme.
All right, thanks.
I'll just make a few comments as well. Some of this will be similar to some of the remarks that Steve just made. With regard to the superficial geologic mapping that was done at the mine site, the work there is state-of-the-art. There are no real issues. The superficial geology appropriately and adequately characterized in great detail, and lots of other details associated with that work with regard to the glacial geologic history of the area. But with regard to similar detail in the transportation corridor part of the study area, I think more work could be done to better characterize the superficial geology and particularly the hazards associated with that transportation corridor. There are likely some slope stability issues, landslide, rockfall issues that need to be evaluated, and the 1 to 250 scale mapping of Detterman and Reed, although excellent at its time, is probably too small a scale to be used for an area like that. So I think some additional superficial geologic work in the transportation corridor area and in the Cook Inlet drainages would be warranted. Let's see. What else have I got here? I'd also agree that additional studies on the Lake Clark Fault are warranted. We want to know exactly where it goes to the southwest, when it was last active, how big earthquakes could possibly be on that fault. And just to reiterate, the glacial deposits that overlie the fault trace are thought to be roughly 12,000 to 10,000 years old, and they are not displaced in any way by the fault itself. So that's where the inference that there's no evidence of activity over that time frame comes from. Of course, that could be refined somewhat by studying those deposits in more detail and trying to get age estimates to pin that down even better. And then I would reiterate that the main volcanic hazards are likely to be ashfall, and as Steve mentioned, these eruptions may persist for weeks, months, and the effects of ash could be a persistent problem. It's probably not a deal breaker, but as we all know, those of you that have been around for some of the recent eruptions that we've had here in Alaska, air travel can be suspended for days, sometimes longer, and that could complicate some issues. And then before we let the subject of volcanology go, I think it's also important for us to bring to light other studies that may have some bearing on what we're trying to do here. And I just wanted to mention an event that happened at Chiganagak volcano, which is located just south of Pilot Point. Many volcanoes in Alaska have crater lakes in them. They have summit craters that fill with water. And if the volcanoes are active, they're going to be releasing sulfur gases, which when they react with water produce acids, sulfuric acids. The case of Chiganagak, that lake in the crater, was very acidic, and it breached catastrophically sometime between November of 2004 and May or April of 2005, and it produced a very large acidic flood that made its way into Mother Goose Lake. It was about 1 million cubic meters in volume, so it was a pretty substantial flow. The pH of Mother Goose Lake went from about neutral to in the 2 to 3 range right after the flood. And yeah, right. needless to say, all of the aquatic habitat along the flood route and in the lake was destroyed. The fish were gone. There was no salmon run that year. But about 3 years later, the fish began to come back, and currently the area supports a pretty robust salmon run. So there are some natural nature performs experiments for us all the time, and we can learn a lot about the robustness of various systems by trying to learn from these sorts of events. My colleagues at AVO have published a couple of papers on this, and I can provide those references. But there is a big literature on acid lakes and volcanoes and their drainage, and they are somewhat of an analog to acid mine drainage. So I think it's important to try and pull in some of these studies, maybe from fields not directly germane to mining, that might shed some light on what we might expect in terms of impacts and recovery. And I think I'll just stop with that.
Okay, Tom?
Okay. I'm going to just restrict my comments to the data at hand, and if there was a mine plan, then there perhaps would be a few more questions coming from me. But really, I guess my principal point is that we have to be careful with this issue of prediction. Prediction is dicey at the best of times. I think if we're using these kinetic tests to predict, say, the future onset of acidification in waste materials or water quality, then there's a tremendous amount of uncertainty, and I think we really have to acknowledge that, and perhaps, we could step back a little bit and say, okay, acid-base accounting works fairly well for identifying materials. Let's find a realistic threshold for the neutralization potential ratio. Let's make sure that there's some risk safety factor built into that, and perhaps, as Claire suggested, then some sort of program akin to grade control, whereby you use, say, rapid analyses for calcium versus sulfur, that could provide the density of data in time and space that really helps in terms of segregation, because segregation of material, if it's going to be done, it has to be done with some confidence, because if you make those decisions, you move material that you think is non-acid generating, and at some point in the future it becomes acid generating, then you've got a real problem. So I think that issue of segregation is important. I think we have to find methods with confidence of doing it, and it deserves a lot of thought and consideration. And humidity cell tests, kinetic tests, and whatnot, I really don't honestly have that much confidence in those. And then the last thing is the business. In terms of the data at hand, I don't think we have enough data on the tailings disposal. And I think that's been acknowledged, the pyrite concentrate. There's really no data for that. We don't know the fractions of the pyrite concentrate relative to the bulk tailings. I think we probably know that it would be a net acid producer, but what we also don't know is how it's going to be treated. I mean, there's a whole range of ways of treating a pyrite concentrate, everything from pressure oxidation through to cyanidation, and we don't know which of those choices would ultimately be used, and they all have their own implications on the geochemistry of the system. So there's a lot more. There's a lot more to be done before all these questions can be answered. But I think at this point the work that has been done is good, and I certainly feel that way. But I do think that segregation is very important. We need to have a program for doing that with confidence, and I haven't seen that yet. So.
Okay, Jeremy.
Okay, so taking the baseline study at sort of face value and thinking about the pebble deposit and the location, to some extent it's an ideal deposit. It's the geographic location is fairly flat lying. You don't have risks of landslides and so forth around the actual deposit itself. The geochemistry of the deposit is fairly benign. There's not a major risk from elements like arsenic or mercury actually within the ore deposit itself. So compared to some porphyry projects that I visited around the world, this is actually a pretty easy task to engineer a good mine. The concern, of course, though, is when you step back a little bit and say, okay, well, where exactly are we? And you look at the mine in terms of its broader context, in terms of salmon fisheries and so on and so forth, then I think that simply focuses the challenge for the engineers to come up with a design which really will work. And I think amongst some of us we've been talking about building in redundancies and fail-safes in terms of one's assurance about water management, tailings management, and so forth. Probably sort of one solution is not going to be enough. We're going to need to multiply the safeguards to really make sure that there never is a significant spill from this operation. I think that's probably a challenge the engineers are up to. Of course, it's always an economic consideration. At some point, the whole project becomes economically unfeasible. But I think today companies, when they're designing mines, they talk about planning for closure. And so I would like to see, as they develop the mine plan, starting from day one, and this is day one, we're looking at the baseline studies, but starting from day one, thinking about the environment that you're building this mine and how are you going to build it so that you can shut it down at the end of the day and it is not going to cause any risk to the environment for the foreseeable future. Of course, we acknowledge that in perpetuity is an unrealistic prospect, but within the scale of reasonable prediction to design a mine that will maintain its integrity after closure for as long as we can plan it. So the mine itself, I think, is a nice operation. It's a wonderful deposit, and I think engineering-wise, we certainly have the capability to design a good project here. So I'm pretty comfortable with what I see at this point. There's no huge red flag that in my mind says you should never dig up the turf here. But there are those longer-term issues that I think we need to build in right from the beginning. The transportation corridor, in fact, is where I have the greater concern about a possible risk in terms of a spillage. And we discussed that a little bit yesterday in terms of landslide risk along the transportation corridor, particularly along the north shore of Lake Iliamna, where the corridor appears, on the current sort of routing designs, appears to run along the lake shore and at the foot of some pretty steep hills. We've heard a lot about seismic risk, volcanic risk, and so forth, and just general landslide risk from steep topography. A significant landslide which took out your transportation corridor and the 5 pipelines that have been talked about running up there to bring ore concentrate down to the coast and return water, oil and gas. You could have a significant spill if there was a landslide affecting that transportation corridor. And I didn't really see much in the baseline study that addressed that risk. So that's something that I think would need to be addressed. Yes, we're being told that there is no plan, but I think any plan is going to require some kind of pipeline. So even if we don't know exactly where it's going to run, I think we do need to evaluate the stability of that region and the risk and the way that one might mitigate the risk to the integrity of a pipeline like that. But so those would be my thoughts at this point.
Thank you. Just a couple of closing comments. First, this is the end now of our first panel review covering the geology, geochemical characterization. The presentation discussions you heard this morning is our bridge to the next panel review, which is on the hydrology. So we've heard about source materials and how reactive they are and the tests that were used to that, but that all has to be taken into the context of the water flow of the system. We have to know something about where the water is flowing and how fast and so forth. And so the next panel session starting after lunch will be on the hydrology. The other thing I'd like to say is that these 5 gentlemen here who have kindly provided their own time to come and review many pages of technical work should be applauded for their efforts, and I personally really appreciate the work that you guys have done to go through this stuff, review it, and ask some critical questions. Thank you.
Let's thank Kirk and Philip as well for their effort.